Good morning, students. Chapter 3, motion in a straight line, continue. Motion. Yes, motion is a relative concept. How relative concept? In previous lecture, I think starting, I have given you one example. Okay, if there is a bus moving, in moving bus there are two persons A and B in bus stationary. Okay, and another person C is on ground. Then yes, with respect to A, B is stationary, but with respect to C, B is in motion. B is in motion. Yes, we have to study here motion, and motion is one relative concept. It depends on frame of reference. It depends on frame of reference, from where you are taking observations. From where you are taking observations. Okay, for example, it is one train. In train, one person is moving in direction of train. For example, it is train. In train, one person is moving in direction of train, and you observe from platform. Then you will find velocity of this person greater than velocity of train. Yes. Okay. It is based on some practicals. It is based on some experiments. Okay. You can also find such examples. Okay. If one person is in car or train, it is moving in this direction. Okay. Then yes, person standing on ground will find that speed of this person is greater than speed of train. Okay, so why? What happens? See, it is relative velocity. Because both this train and this object, they both are moving in same direction. So whenever third person observes, he will find its speed greater than both of them. Okay, now what is relative velocity? What is its actual meaning? What is equation? That we will study here. For that, we are taking one example. Consider two objects A and B moving uniformly with velocities VA and VB in one dimension. That is, say, x-axis. See, at time t is equal to 0 means initial position. X-axis. A is here, B is here. From origin, position of A is XO. At time t is equal to 0. From origin, position of B is XBO. So very simple. At time t is equal to 0, position of X, position of A, XO, position of B, XBO. Clear? Okay. Now as they are moving, this A is moving with speed VA and this B is moving with speed VB. So after some time, yes, these positions are changed. Okay, they both are moving in same direction. So let at time t is equal to t. After some time, from origin, A is here and B is here. So position of A, let it is xn. Position of B, let it is xb. Clear? So here we have two situations. First, at time t is equal to 0, position of A and B are XAO, XBO. At time t is equal to t, position of A and B are XA and XB. Clear? Now we have to write equation of XA and XB. Okay, what is position at time t is equal to t? See how to write. Here it is very easy. Initially, object A was here. Yes or no? And you know what is this distance? This distance is XAO. Yes or no? It is moving with speed VA. What is time interval? T. So with speed V in time T, what is distance traveled? You know this equation. V is equal to x upon t. So x is equal to vt. It means with speed v in time t, distance traveled x is equal to vt. Again, understand how to relate this. With speed v in time t, distance traveled x is equal to vt. So here initial position of A was xao. It is moving with speed va. So in time t, what is distance traveled by it? Yes, distance traveled by it is va into t. So see how to write this position at time t is equal to t. xa is equal to xao plus vat. xa is equal to xao plus vat. Clear? Okay, see if I give you example. Right now I am here from this corner at time t is equal to 0. So what is this position? What is this position? XAO. A for Asif sir. Okay, I am here at time t is equal to 0. So from this origin, my distance is, my position is XAO. Now I am moving with speed VA. Now I am moving with speed VA. In time t, now I am here. Okay, so what is additional distance travel in time t? VAT. What is additional distance travel in time t? VAT. So now what is total distance? XAO plus VAT. XAO plus VAT. Clear? So at time t is equal to t, if I want to write this XA, how to write this XA? XA is equal to XAO plus VAT. If you know how to write XA, you can easily write how to write XP. XP is equal to, yes, it is XPO plus VBT. Then see how to write. Now the positions at time t is equal to t are given by XA is equal to XAO plus VAT, where XAO is initial position and VAT is another distance traveled in time t. Similarly, XB is equal to XBO plus VBT. Okay, if now we take that difference, that is displacement from object A to object B is given by XBA. Displacement of B with respect to A. Displacement of B with respect to A. So XB minus XA. XB minus XA. See how to take minus. XB minus XA. XB minus XA is equal to XBO minus XAO. XBO minus XAO plus VBT minus VAT. T common, so it is VB minus VA into T. Clear? So you have to remember this equation. XBA is equal to XB minus XA is equal to XBO minus XAO plus VB minus VA into T. Where what is XB minus XA? XB minus XA is relative displacement at time t is equal to t. What is distance between A and B? It is called XB minus XA. It is called XB minus XA. Okay, similarly, XBO minus XAO, relative displacement at time t is equal to 0. Here it is. It is XBO minus XAO. XBO minus XAO, you can also say initial distance between two objects. Initial distance between two objects. And XB minus XA, final distance between two objects. Final distance between two objects. Yes. What is XB minus XA? Final distance between two objects. What is XBO minus XAO? Initial distance between two objects. Now what about this VB minus VA into T? This VB minus VA is called relative velocity of B with respect to A. Okay, as seen from object A, object B has a velocity VB minus VA because the displacement from A to B changes by amount VB minus VA in unit time. What is this VB minus VA? This VB minus VA is velocity of B with respect to A, relative to A. How to write? See, we say that velocity of object B relative to object A is VB minus VA. How to write? VBA, velocity of B relative to A. Velocity of B relative to A is equal to VB minus VA. Similarly, the velocity of object A relative to B means V VA minus VB. Okay, now from these two equations you can say that they both have same magnitude but opposite direction. You can also calculate this. You take VA is equal to 100, VB is equal to 60. Okay, then what is VBA? VB minus VA? Yes, it is minus 40. And what is VAB? VA minus VB? It is 40. So see, one is minus 40 and another is 40. Okay. So these equations you have to remember. Now we will see in detail what is meaning of these equations. What is actually relative velocity? See here, I have two objects, A and B. They both are moving in same direction. Speed of A 100 km per hour, speed of B 60 km per hour. So what is relative velocity of A with respect to B? What is the relative velocity of A with respect to B? VA minus VB. Remember, as they both are moving in same direction, you have to consider their velocity positive. VA plus 100 km per hour and VB is equal to plus 60 km per hour. Okay, and if you put data, VAB is equal to VA minus VB, 100 minus 60 is equal to 40 km per hour. Okay, so it is meaning of relative velocity. Okay, yes, actual velocity is 100 km per hour, it is 60 km per hour. But when you take speed comparative to another vehicle, then yes, it is less. For example, you are in a car and one car is moving behind you, okay, or ahead with same or some slight different velocity, then yes, if you are on speed 100 km per hour or 120 km per hour, there is no more changes between distance between two vehicles. Why? Because between two vehicles relative velocity is less. If you have observed, when two cars are moving or two friends are moving on a vehicle, Activa, bike or whatever, with same speed, then see, they are moving parallel, means their velocity is equal in same direction, means the relative velocity will become zero. They are not changing their position with respect to each other. Okay, but yes, if one student increases its speed and of other it is less, then yes, one will go forward and forward. Okay, so it is meaning of relative velocity. Another example, if A and B, they are moving in opposite direction, okay, A in this direction, B is in this direction, then remember, when two objects are moving in opposite direction, take one as positive and take another as negative. Okay, take another as negative. So whenever two objects are moving in opposite direction, VAB is equal to VA minus VB. VA 100, it is minus, and VB is minus 60, so it is 160 km per hour. Relative velocity between them increases. See, one simple example. If two vehicles are approaching towards each other, then yes, they will approach each other very fast. In short time. Clear? Okay. Pause your video. Write down from board. Okay, we have derived one equation, that is xv minus xa is equal to xvo minus xao plus vb minus vk into t. Again, xv minus xa, distance between two objects at time t is equal to t. xvo minus xao, distance between two objects at time t is equal to 0. vb minus va, relative velocity. Okay, t is time. Now we have to consider some special cases. First case, if vb is equal to va means both vehicles are moving with same speed in same direction. Both vehicles are moving with same speed in same direction. Okay. Then if Vb is equal to Va, then Vb minus Va is equal to 0. So VAB, velocity of A with respect to B or velocity of B with respect to A, it will be 0. And if in this term you put 0, then what is your answer? XB minus XA is equal to XBO minus XAO. It means distance between two objects is constant. Distance between two objects is constant. See how? Here, it is B, A. They both are moving in same direction with same speed. With same speed, with same speed, with same speed, with same speed. So see, at each and every time, distance between them remains same. Distance between them remains same. If two vehicles, it is B and it is A, they are moving with speed 100 km per hour, then yes, if you observe, another vehicle at each and every time will be at the same distance. Okay, if you are in train, a car is moving at a speed of train, okay, then you will observe, okay, yes, that car is moving with you, that car is moving with you, that car is moving with, yes, okay. So it is first case and it is easy to understand. If Vb is equal to Va, then Vb minus V is equal to 0. Xb minus Xa is equal to Xbo. Distance between two objects is constant. XT graph are straight line parallel to each other. How? See, XT graph are parallel to each other. Parallel to each other means their slopes are equal. Their slopes are equal means if slope is equal, then velocity is also equal. See, initially distance between them is this. It is distance between them. At each and every point, if you find distance between them, it will be same. And yes, they will never meet each other. Clear? So it is first case. Easy to understand. Okay. Second case. VA greater than VB. Remember your figure. A is here and B is here. A is moving in this direction, B is moving in this direction. Its speed is VA, its speed is VB. See, VA greater than VB. Speed of this object is greater than speed of this object. Then you know this case. You know case of overtake. If one vehicle is moving and you want to overtake it, then yes, you have to increase your speed. If you increase your speed, initially distance between two vehicles decreases, then it will overtake and then distance between two objects will increase. So, you know case of overtaking. Initially distance between them decreases. When one vehicle overtakes another, their positions becomes same and then distance between them increases. So here VA is greater than VB. VB minus VA is negative. So one graph is steeper than the other and they will meet at a common point. Now what is meaning of this? One graph is steeper than the velocity. See, VT graph, we know VT graph, XT graph, all graphs. Okay, in XT graph, slope is more than velocity is more. Slope is less than velocity is less. See here, VA is greater than VB. See, it is graph of A and it is graph of B. From this two graph, you can easily say slope of A is more than slope of B. Slope of A is more than slope of B. Okay. So if you draw graph, from that graph you can write each and every points. See, initially distance between A and B is this. Initially distance between them. Now see, distance between them decreases. At this point, distance between them will be 0 because their positions are same. Means they overtake each other at this point. Okay. Okay. And after overtaking, yes, distance between them increases. Distance between them increases. Distance between them increases. You know what is case of overtaking? Clear? Okay. Initially, distance between them increases. They meet at a common point, and then distance between them decreases. Distance between them decreases. Clear about this second graph? Okay, when VA is greater than VB, means speed of this vehicle is greater than this, then A will overtake B. Then A will overtake B. Now third question is what? See, if speed of B is greater than A, speed of B is greater than A. Suppose it is moving with 100 km per hour and it is moving with 50 km per hour. Then what happens? Yes, this vehicle is moving ahead and ahead, ahead and ahead. Yes or no? Yes. And distance between them increases. Distance between them increases. Will they ever meet each other? No, they will never meet each other. So see, if VB is greater than VA, now VB is greater than VA means slope of graph B is more than slope of A. Then see, from graph you can say initially distance between them is less, then distance between them increases, distance between them increases, distance between them increases, distance between them increases, and they will never meet. Clear? Okay. Last case. If A and B, they are moving in opposite direction. If A having speed kilometer per hour, B 60 kilometer per hour, then we know that in this case the magnitude of VBA or VAB is greater than the magnitude of velocity of A or B. Hello, here VAB is equal to VA minus VB, as they both are in opposite direction. 100 minus, you have to take this velocity as negative, and is equal to 160 kilometer per hour. 160 kilometer per hour. Okay. For two trains moving in opposite direction, other train seems to go very fast. Yes, you can also observe this on two-wheeler or four-wheeler. If two objects are moving in opposite direction, then yes, you observe that yes, it is moving very fast. Hello, that object is not moving very fast. You are also moving, that vehicle is also moving, so relative velocity between two vehicles increases. That's why we can see that object is moving very fast. Okay, so it is due to relative velocity. For this fourth case, see, initially distance between them is small. Now they both are moving in opposite direction. VA, its velocity we have to consider positive. VB, its velocity we have to consider negative. Positive means see, graph of A, it is in upward direction, and graph of B is in downward direction, representing negative direction, negative velocity. Okay, so at this point they will cross each other, and then they will move in their respective direction, Two vehicles are coming, yes, approaches towards each other, crossing, and then they will move in their respective direction. Clear? So it is one relative concept. If you think, you will easily understand. If you have any doubts, then send me doubts.